we can talk for just a moment about a couple of very important biological carboxylic acid derivatives, and I really only mention this one because acetyl coenzyme A, which is a thioester, it's a key compound in many biological processes, whether it's biosynthesis, so the way that your body makes fatty acids and proteins and things like that, as well as metabolism, the way your body breaks down everything that you get, whether it's sugars or fats or proteins. Go into chapter 29 if you get a chance and just look at the one figure in there that on page 1126, that figure shows the main roadmap of cellular metabolism. This compound, acetyl coenzyme A, or acetyl-CoA, is a key compound to all of that. So let's just talk about, first of all, how acetyl-CoA is made. Here's just regular CoA, and the important part is just here, right? Regular coenzyme A is just a thiol, okay? So SH, and then all this other stuff, it's got an adenosine biphosphate attached to it. Just comes from its synthesis. That is acylated by acetyladenylate, okay? Very similar to acetic anhydride, AC2O, in that this SH of coenzyme A is the nucleophile, and this phosphate group over here, OPO3, essentially with an adenosine attached to it. All this is a leaving group. So what we've done is added an acetyl group to coenzyme A. That's why it's called acetyl-CoA. So we have CH3C double bond O, S, and then the whole rest of the CoA molecule. So that's important then because acetyl-CoA itself is an acylating agent. It's really the body's key acylating agent, right? Any nucleophile can add to that acetyl group at the end of CoA, and then the rest of it acts as the leaving group. So if we want to add a CH3C double bond O to really anything in the metabolism process, acetyl-CoA is how it works. And it's hard to underemphasize the importance of this molecule, that all carbons from the metabolism of whether they're fats, carbohydrates, and proteins, they're all converted to acetyl-CoA. So every carbon molecule that you eat, whether it's a fat or a protein or a carbohydrate, it's broken down through the metabolism process to pairs of carbons, to these two carbons in acetyl-CoA. And then acetyl-CoA passes those on to the rest of the metabolism process, like the citric acid cycle and so on. And then the way that biological systems synthesize fatty acids and so on is because of these two carbons, and that's why most biomolecules have an even number of carbons, right? All fatty acids come in even numbers, right? 12, 14, 16, 18 carbons. That's because they're made 2 carbons at a time by acylation with acetyl-CoA. So it is the biological acetylating agent. It adds an acetyl group to any number of biomolecules. So if you go on to biochemistry, keep this chapter in mind quite a bit as you're looking at the reactions of those important biomolecules.